Hey everybody, and welcome to McArdle Math Academy. In this video we will be doing another example of integration by parts, and this example requires us to do integration by parts twice, as we shall see. Alright, so we're given this integral. Obviously the first thing we try is integration by substitution. You're going to see that doesn't really get us anywhere, so then we try integration by parts. And the procedure is that we first choose a u and a v prime. So again, we want to make this integral be in the form u times v prime dx in order to apply the formula for integration by parts. So as a general rule, we set v prime to be the most complicated part of the integrand that we know the integral for, and that would be this cosine of 2x part, because we know that that's a pretty basic integral by substitution, which we'll do in a second. That leaves x squared to be u, so u is the remainder. From there, after we make our choices, again that takes a little bit of experience, we will compute u prime, so we find that that's 2x, and then we're going to compute v. So v is always going to be the integral of v prime, which is cosine of 2x, all with respect to x. And we want to do this little integral here, so essentially it's a small little substitution where we let w be 2x. You find the derivative of w with respect to x to be 2. You solve that for dx. And we make these substitutions into the integral, so you'll find it's the integral of cosine of w times dw over 2. So therefore the final answer is sine of w over 2. And you're going to then substitute back what w is. So we get sine of 2x over 2. And a lot of you can do that in your head at this point, but I just wanted to show out the work for finding that. So now we have our four pieces of information. We have u, u prime, v, and v prime, and we apply our rule. So the rule says that this integral will be equal to u times v minus the integral of v times u prime, all with respect to x. Again, this is the integration by parts rule. And then we plug in what we have. Alright, so we're going to remember what we set everything equal to. U is x squared. V is sine of 2x all over 2. We're going to subtract the integral of sine of 2x over 2 times u prime, which is 2x, all with respect to x. Alright, and we're going to simplify this a little bit. So this first term doesn't move, and the final integral becomes x times sine of 2x, all with respect to x. Okay, so when we look at this integral, this new integral that we have to solve, we notice that we're going to need another integration by parts. Excuse me. So that leads us, let me get my right tool here, to come over to the side, and I call this the sidebar because it's basically a problem within a problem, to do this second integration by parts. Here we're going to set u to be x and v prime to be sine of 2x. Again, we compute u prime is 1, and v is the integral of sine of 2x, all with respect to x. I won't do this one out formally, but this is going to be negative cosine of 2x, all divided by 2 in this case. Okay? So we have written this integral now in the form u times v prime with respect to x, and we can apply the rule. So the rule says this is equal to u times v minus the integral of v times u prime with respect to x, and we're going to plug in what we have. Alright, so plugging in what we have, we end up with this new formula here, and we can rearrange this a little bit, so we have minus x cosine 2x all over 2 plus the integral of cosine of 2x over 2 with respect to x. And this integral on the side here, cosine 2x over 2, again, that's a pretty basic integral by substitution, and you're going to find that the answer is sine of 2x over 4. Alright, so we finished here in our sidebar. So we're going to circle this. Let me zoom out here so we can kind of see the whole big picture. We started on the left here with this integral. We're doing this integration by parts, and we got to a point here. So we get to this integral here, at which point we had to come to the sidebar. So we're going to come back. We're going to bring this piece back to the start. So we come back to this integral here. Don't forget the minus sign. Zoom out a little bit. So we have x squared sine of 2x over 2 minus, and then in green we bring back what we had from before, which is minus x cosine of 2x over 2 plus sine of 2x over 4. Okay, and distributing that, we'll arrive at our final answer of x squared sine of 2x. Again, all I did in that case was distribute the negative sign. Alright, and that's our final answer. If you take that answer and you find a derivative of it, so if we differentiate this here with respect to x, we'll end up with x squared cosine of x. And you can do that as an exercise on your own. Alright, thanks guys, I'll see you next time.